Okay, good morning, folks. We are live. Hi. Real quick here. Let's just get some new windows. These are kind of off. The plan for today, we need to fix the multi-discrete bug. We'd like to get several other environments bound and working with Puffer 4. More refactoring, and hopefully we can get some of the more complex M's, because there are a few tidbits I'm not sure how I want to port yet with the old M bindings. So we're gonna have to figure that out as well today. Okay, so let me now that I'm here, let's go figure this chunk out. Kernel set to false, right? I'm gonna get one other window here, which is just gonna be for testing. Make sure we still have breakout working. Okay, yeah, this still works. Right? Still trains as expected. Does it? Yes, it does. It's just very slow. Look at that. Without CUDA graphs or kernels on, it's very slow. Well, by Puffer standards. And now we have target. Yeah. So apparently, the error surface is much larger than I thought. So this is what I got stuck on last time. I had thought that I had it working without the kernel, but I don't think I did. So we need to actually now go and isolate the bug correctly, since I did it wrong last time. Here's Puffer target. And this should learn virtually instantly, this environment here. And you can see it. This one's weird. It has to be based on episode length. But yeah. Clearly this doesn't work. Okay, so questions. SPY. Yeah, enough trolling, my dude. They're building stuff here. Why do you look so sad? Like I just woke up because I just woke up. And we also have a bug to fix today. So I think the way to do this would be morning routine. I mean, I got a shower, I shaved, I went and I made myself my morning protein drink, and then I just booted up the stream. On Saturday, I try to just, like, really work the whole day if I can. I was actually a little slow today. I would have liked to have been live, a half hour earlier, but that's alright. Wait, did it do the exact opposite? Oh, this is fine. It can do it the other way first. Self-motivation like this. Just the fact that I've had way, way, way more motivation at other points in my life and like other blocks of work. So like if you do a couple blocks of work where you're really just doing absolutely nothing but focusing on your thing, then the your default setting is going to be much higher than most people, even when you're not doing that. Hello, Jonah. Oh, hey. Yeah, you wanted to chat about kernels. 1 second. Let me go grab one thing and I will chat with you on that. Morning all. So what are we looking at with these kernels, man? Actually, I'll finish this test and then I'll just undo all this crap and we'll have a nice clean version to test them from. So pulling the PR up as well. Yeah, the thing is that this test is freaking backwards, so this isn't going to tell us much anyways. Yeah, so this one I had left it in float 64 because we were doing correctness test, and I don't... yeah, this was for correctness test before. This speed up as expected. I did this exact same thing with my other kernels. Better walk to speak. Message on Discord. Yeah, Discord's good. I can hop in the voice if you prefer as well, or just type in Gen or Dev or whatever. I have this up on my other monitor. Wait, FBR, isn't your stuff super heavily AI? I think I've read a few chunks of your code. I know you definitely produce, like, new projects at a very suspicious pace. Maybe you're very productive, I don't know. Okay, this trains. The fact it trains poorly is kind of fine. Wasn't getting any precision issues in my tests in float 32. I don't know what tests you're running. So log cum sum exp is fine, man. The let me explain stuff. So when I was developing the fuse scan kernel, right? So the fuse scan kernel has a log cum sum exp internally in it, I believe. Yes. So I did this as a standalone because the fuse scan kernel was very difficult to get correct. So for this one, right? Did you add? No, I don't see you've added the test here. So this one is a very, very important kernel. Oh wait, you did add this. Commented yesterday. Wait, am I stupid? Did you have this Did you have this attached already yesterday? No, wait, this is yesterday. Okay, commented yesterday. Fine. So we have. Okay, right, combined. Okay. 2.3x forward, 1.03 backward speed up. Okay, I will go test this. Let me figure out what the heck is going on here, and I'm just going to copy this code over and test it. And if it is, then I'll integrate it formally. This is new PR, yeah, okay. Hold on, let me finish this train of thought real quick. So, the fact that this does... Wait, did I do this? Okay, no, this wrote a completely stupid test. Okay, cool. Yeah, I wasn't paying attention because I was having a conversation at the same time. I know there is a test that we can write that we will be able to isolate this bug. I will go check your kernel first though. Undo this prep. Good. So we're gonna test we'll test the kernel speed. We will test end-to-end speed, and we'll test numerics. Okay, so we have clean starting point. I also have to do kernels on and CUDA graphs. It has to be, we need the lowest overhead setting for this test. Okay, there we go. There's our 10 mil. Yeah, 10 mil. And we also have our profiler. I had to make some random changes to vecenv and profile because I was having build issues. I don't know why you would have to change vecenv. Of course, it makes sense you'd have to change profile, maybe. Oh, well, because I'm dumb here. Check the PR. Yeah, this was just half-baked, most likely. Oh, wait, that's a lot of changes. Hang on. Run. Oh, okay, because you added as a checkpoint method. That's fine. So yeah, this is fine. We'll take this. Yeah, this is good that you added this as a separate one. That's nice. Let me fix this first. I don't know what version you were working off of. We had the modules thing. I don't know if this is the same version as you were working on. Let me fix this and then I'll integrate. Yeah, this. Okay, you already have this fixed up here, right? Okay, you're on the same version then. And what we need not vecend. This. Yeah, you're probably on the right version then. Hang on. I can probably just take your file. Let me see if this works. If not, I'll just take your whole file. And then what I'll do is I'll test this locally, and if it works, then I'll just formally merge it. I do want to actually understand this like quite carefully though, because this is the most important kernel. Yeah, okay, so this is our yeah, this is this file just being stale. Let me take your version. Oh, you needed the vecend as well. Okay, hang on. Let's see what you did in vecend. Oh, yeah, this is dated because we're is this getting called in here? Because we don't use this anymore. Dict, I think it's just dict set now. Yeah, it's just dict set. That's why. So what I figured out is we don't need to have it conditioned on type. We can just use a double, and a double will have all the precision of for all the ints anyways. Okay, that ought to do it. Yeah, I updated some other stuff and I didn't update the test yet. So there, like this should work. A better vimrc. You don't like my vimrc? I mean, what stuff, right? I don't like to have like a ton of extensions and such. What the heck is this? I thought we had oh I didn't port the kernel, I'm dumb. And add your kernel. Let me get your kernel. Okay, so you added this checkpoint interval, right? And then you added the new checkpointed fuse scan. Wait, huh? Fuse scan wait, fused scan. Okay, they're just weirdly in order, like they're weirdly ordered, right? Because it should be fused scan checkpointed. So this goes here. And then we need your backward kernel, which is not this one. It's down here. Oops. Can't live without relative line numbers. I mean, you know I can just, was it numbers? What the heck is it? Set number. This? This what you want? I mean, I intentionally program without them. Oh, and then the freaking wrappers. Yeah. Those wrappers are so bad. Oh, and then it's gonna have to be the module. Yeah, we need to go get your wrappers too. I don't want to have those stupid wrappers. They're like, that's very obnoxious. The way that it is right now. Oh, I need the launch functions as well, duh. Launch function, and the wrappers, right. I mean, I should have just checked this out, and, we'll just do this real quick. And we'll do it correctly thereafter. If this one works, then what I'll do is I will, I'll like to start, like, I'll probably just make a clean commit of this and I'll start merging your other ones. I just want to see that this is actually tested correctly as a new contributor, right? That's pretty much all. Oops. Cursor with Vim plugin. Nah. I actually do want the I would rather have the AI tools in my editor rather than in this other stupid window. But I do not believe you need a different IDE for that. Okay. Oh, and the wrappers as well. Just click on. Mm. Things important to get faster. How should I try prioritizing certain things? Well, we have the full profile, right? So you could run, like we have NSYS set up nicely with a bunch of hooks. So you can see exactly how much time everything is taking in training. I'll show you in a moment. Um, yeah, this is just a pain because I was in the middle of doing this other thing, and I had not fixed, man, let's just go do, here, let's go do this. Try this. And then I will see if I can go run the profiler and stuff. So you can see. We have a pretty nice setup where we can see exactly the time of everything being spent. Dude, how is this still screwed up? What? Okay, it's actually several things are stale. Yeah, these are just stale. That's all it is. I think this changed yesterday. It's just stale signatures. I did a little refactoring before. So if you're looking for the nsys command as well, so we have this nsys command here for profile kernels. You can get breakdown of the forward call, train forward. So you can actually get all the different calls that are in the network. You can also run it on training itself. If you run nsys on training itself, I can get you the exact calls. For building 4.0 had from changes. Yeah, so it's because I was in the middle of messing with multi-discrete last night. That's basically it. Let me fix this stuff up so we can get get your stuff tested, and if it works, it'll actually a very nice contribution. I'm curious to see the speed diff though. I mean, it should be able to be quite appreciable. Possibly 11 mil. Yeah, this is me just having I've just let the test get stale. Yeah, there you go. This is the new signature. I don't know if I can use MSys. If that doesn't give access. You can't use NCU. Oh, um, I think NSys works and NCU doesn't, man. I'm pretty sure NSys works. I'm not positive. Maybe it doesn't. I remember NCU being a pain. I think NSys is fine. Oh yeah, no, like if you, from the profile you sent me before, you were already running it, weren't you? Or we were just running the numerics? Why am I only getting one output here? Oh, you dummy. There we go. For correctness and actually call the new kernels. That is good. So presumably you did not add the module for this. But that's fine. That's super easy. Backward. Torch. Wait, fuse scan. But wait, where's the fuse scan profile? Fuse chin. There is a checkpointed one. I don't see one of these. Is it profile checkpointed? No. Is there a profile for the checkpointed version? I don't see one. I see create view scan args. I see test checkpointed correct. It was logged to standard out. Am I blind? Oh, yeah, I'm blind. Okay. Oh. That is very nice. Okay. Huh. Okay, well, we will run this for comparison. It's likely that that is a fair bit faster. I don't think, the one thing that I don't have, which is a little bit irritating, is I don't think I have a forward versus backward profile check. Though actually, I think we can probably eyeball it here. How much do I think this would save us? 30 microseconds off of it? 40 microseconds. And it's a forward plus backward pass, which is 15% of the time. That's probably like a good 76. That's probably like 20%. Okay. It might be noticeable. It might be like visibly noticeable. I think it's like hard to say for now. Let me go see what other kernels you have as well. I'll have to add your credit as well for this. Provided this is stable. Okay, so this kernel here, Jonah, this kernel here. So I think this would be a nice kernel. This is a nice kernel to have for us. Online softmax. We're doing an online softmax in both. Oh, okay. Huh. In favor of recomputation. Cool. So this kernel would be nice, except that this one I didn't get to be numerically stable yet. Like if you run the correctness check, because there's the Python correctness check, the old one, that doesn't pass, and then this one destabilizes training still. So we want to use this kernel, and it will actually give us a nice little bump to perf. It needs to be stable though. There's a bug in the PPO kernel. Yeah. I don't remember. I remember I started looking at that and trying to figure out what was wrong. The original? Yeah, there was a bug in the original. I can confirm. Okay, cool. This copies this over. Oh yeah, do you have any thoughts on BF16, by the way? Because I was looking at this and I was trying to figure out whether this is worth it. So from what I can see, right, the map moles are really small. BF16 probably is not huge for them, but maybe there's bandwidth savings to be had doing BF16 for some of the kernel ops. But I think numerically it's pretty sketchy to be doing the activations in BF16. So I was trying to figure out if I want to even support it at all, right? Like maybe for element-wise gate ops like this, we should just drop BF16 and then we can get rid of all the templating and everything can be much simpler. You know? I guess the one annoying thing is if you do your training in BF16, then you have to do the additional cast before the kernel otherwise. So I was using double originally for numerical tests, man, because I was trying to make sure it wasn't a precision issue. So when I was writing the kernels originally, that's why I was using double. Because I was sort of wondering, like, you know, if instead of having all these freaking kernels support this, maybe it would be easier if I wanted to support BF16 in the first place to just have, like, the output, like, fuse with the matmul cast to float 32 for the output instead. I don't know. Cast back to store. Which is how it's done now, right? It's just obnoxious because we have everything. We have to have everything templated. Keep your values in BF16. I guess then what would that be? We would do that is actually worth considering though, wait, right? Like, is that a thing we can do? Can we do can we keep all our activations in BF16 like that? Keep the weights in 32? I think that does actually work, and that would actually make it faster. That's worth looking into. And then maybe we can just do BF16? I don't know. I'm really just sick of this templating, you know? It's just really obnoxious. It makes the code a total mess. It'd be better if we didn't have to have multiple D types. If we just have one thing and it's stable, then we're kind of set. Oh yeah, by the way, for anybody who's trying to follow this conversation with Jonah, we have the, maybe I should leave the Discord window up here. In double. Yeah, I know that that one is slow, man. That kernel was like, we do want that kernel, but it's not currently being used as is. Like, the code for that is copied in float into the other kernels. Okay, I do think that this is a little bit faster. It's tough to fully tell visually, but I'm pretty sure this is a little faster. It's stable either way. Is it being used? So let me see if I can get the NSYS profile for you to show you that thing. And then we'll get your other ones. The GPU. Okay, well then that's actually legit, yeah. I mean, I was getting the sense that, like, I would be shocked if you were just fully vibing this. Because the models are not good enough to just do this directly. I know. So I asked if you were a kernel dev, and you said, like, not really, no, but, like, if you've actually gone through the material, that makes you better than 90% of the people that are just, like, trying to claw their way through everything now. See, I didn't go through Elite GPU or anything, Jonah. I just basically, I've been doing C for the last couple of years. And in my mind, it's just like, C that runs on GPU, C that runs on CPU. I understand what bandwidth is. I understand what flops are. Man, no big deal. At least before you get to, like, you know, at least for trivial kernels that don't have fancy synchronizations. Okay, let's see if this gets it to us so we can show you the full thing, yeah? There are a couple different modes that you can run this with. So these are the single kernels, right? This is the kernel you added here. We can see right here that your kernel is faster. This is the profile test you ran. It's about the same for backwards. And some, like, significantly faster forwards, right? And torch check failed. Lovely. What the hell is wrong with this? Ugh. Oh yeah, this is just, hang on, let me fix this mess. Damn it, the train forward call profiling. Well, that's just great. And that's what happens when tests get stale. Obsessed with SPS meaningful performance metric given SPS Mave. So Kilamaria. So yes, you can gimmick it. If I were just trying to publish a paper and put the highest number out there possible, then yes, I could gimmick it and I could get 30 or 40 million. But that's not what I'm trying to do. I'm trying to actually make this stuff work. So like I have controls, right? The target was 10 million SPS with 8192 environments, 2 buffers, and 32k mini batch size. So I have reasonable constraints under which to hit this target that prevent me from doing like janky things that don't actually make a difference. So you will see, I can guarantee you that you will see when I put this update out that all training across the board just gets meaningfully better. And especially when you're doing sweeps, you're going to notice that a lot of the configurations of sweeps that were very inefficient before are suddenly just stupidly fast. Because the optimizations I'm doing here are all like, they're all overhead reduction, if that makes sense. So pretty much any training configs that would be more affected by having overhead on all the little calls before will be less affected by that overhead now. Training runs that were already like pretty heavily GPU saturated will not benefit as much, but they will still benefit because the overhead's just across the board and I'm not doing anything that would hurt those runs. To the point of that, right, I ran Neural MMO yesterday with like the same model from before that was 500k in Puffer 3. It's a bigger model and it's 750k now in Puffer 4. In test speedup log, you can remove the first branch at least. Oh yeah, that was the thing that we were talking about before. That could actually be nice. Let me figure out what the heck is wrong with this this profile first. This is in narrow. I mean, surely something's just out of date here. I can actually take a better look. That'd be good. I want to get that PPO kernel working for sure. My task at the moment for today, I need to get multi-discrete working. I think multi-discrete is going to be very easy with the kernel. It's a total pain in the ass without a kernel. I don't think that the problem that we're having with that is with that kernel though. That's just like a bunch of things have to be changed to support that. We're also going to need continuous sampling at some point. Relatively soon, maybe even later today. But yeah, honestly, just like improving our core kernels is very helpful. I think that the big ones are the Mingru gate kernel is leaking, I think like maybe good 10% of our profile time if I remember. And then the fuse scan kernel is the really big one. Like most of our wasted time is in fuse scan, and then there's kind of a long tail of other ops. If you could fix the PPO backward kernel so it's numerically correct, that would also be huge. What's this multi-discrete kernel? So instead of sampling a single action, you have some environments that have multiple actions that they take. And if you try to write that down in a torch operation, you get a complete and utter mess. If you try to write a kernel, it's actually very easy. But I will be able to fix the kernel for that. It's the torch version of the code as well as the environment updates required that are messing with me for that. That's what I was doing before you hopped on. Okay, yeah, see, this signature is just out of date. That makes sense, thanks. Yeah. So, I mean, this is kind of the cool thing about having good incentives right? The problem with being in academia, and when I was in academia, right, if this were going to be a paper, I would be forced to optimize for really stupid targets, right? Like I'd have to do 32 kms or something and not care as much about overhead or something like that because there would be some other paper that had also gimmicked it and like gone with completely dumb testing constraints, but reviewers don't understand that. But because I'm no longer in academia and now I'm just here on my own trying to make this field work, I can just ignore all that noise and just test under the conditions I know that actually matter, right? So you don't get as crazy of a number on paper, but when you actually go to use the tool, it works, and you go to use the other tool, it doesn't. The one thing I'm absolutely not happy about with this is the amount that I'm having to use Claude to refactor crap in here. It's pretty much entirely just because of how verbose and redundant all the code is, right? Like I can't ever just edit one line somewhere. I have to edit that line in 10 different places. My hope is once we figure out if we can just like have one D-type path and not have these crazy headers everywhere and clean up the bindings, I'm hoping it will be less redundant and more human friendly. But for now, it's kind of like I'm cleaning up somebody else's mess in a sense, because this is what Torch does as well. Actually, Torch does it even worse. They put everything in macros, so stuff just breaks with no error message. Yeah, so the min group gate is actually pretty darn quick already. I guess the thing that could be done with the min group gate would be oh, actually, Jonah, do you know how to fuse do you know how to fuse gate operations with the matmuls? That's one of the things I've been trying to figure out because I know that there's this like fancy epilogues thing that's kind of annoying. But because you don't have like the open source NVIDIA matmul, I don't know if there's a way to nicely fuse arbitrary element wise kernels to the end without making a total mess. CUDA out of memory. Yeah. Like FMA. So the idea being instead of launching the matmul kernel and then launching the mingru gate kernel, like is it possible to do it so that I guess the way I would explain this is if we had the source to the matmul kernel that NVIDIA uses, you paste the matmul kernel and then you paste the gate kernel in one kernel. I guess I don't know how the reductions work in that. So like there might be an extra sync anyways. But you should save the memory bandwidth, right? Of like having to load the memory back into the gate kernel. But I don't know how to do it, right? Because you don't have NVIDIA's kernel. So like they have this fancy epilogue crap, which is I think their C++ templated library. I don't know if there's just an easy way to like fuse arbitrary element-wise ops to the end of matmul. And we don't really care about the launch overhead because we're graphing stuff anyways. Like, we have CUDA graphs on anyways, but you still care about the bandwidth. And, like, you know, the Mingru gate kernels, it's very fast. It's like 6 micros, but it gets cold in a very tight loop. So it might be significant. Where are you doing the matmos? The linear layer. Oh, okay. This is what I was trying to show you. Let me see if this one works. Okay, so there's still jank, but look at this, right? So we can do this one. Where's it? Forward call. So this is the basic profile for forward call. So this is the entire forward pass of our network. You see graphed, it's 51 microseconds for our forward pass. And then yeah, and then we do this one. Okay, here. So you see this? Actually, this split K should not be in here. I think this was introduced by some of the new stuff I'm doing with the Logits kernel. So this should not be in here. But you see this? So this is the forward pass, right? So I can run the NSYS version. And this tells us we have 81% of the time is spent in these matmols. And then we have 8.6% of the time in the Mingru kernel. And once I fix the train one, you'll be able to do this with the train version too. Like the train calls, which I think is just here. Yeah, it's just the shapes were wrong. Hang on. And then we'll see if we can get the train call work. So I spent quite a lot of time on that, and you can see there are only 4 different kernels here. And actually, this split K reduce, I think this can be gotten rid of as well. So it will actually just be 3 kernels. If you go profile some arbitrary torch code, it'll be a bajillion little stupid kernels. Cloud code is stupid. It is stupid. The models are all very stupid. They are. The thing that I've changed my mind about, though, is that they are actually helpful. It's actually funny. The more that I use the more I use the model, the more I think it's actually pretty stupid, even though it is helpful. It's actually kind of better that the model is sort of stupid. Like, as long as it has very high accuracy in applying very well-defined transformations to the code, that's kind of all I needed to do. still out of memory? Heck. Yeah, it's out of memory. Okay, well, we'll have to fix this as I fix the multi-discrete kernel, man. But you kind of get the sense. Matmals are from regular and then linear. Yes, exactly. So that's kernel 2 in that profile that I showed you before. Where is it? Okay, so this one here, kernel 2 is matmul. This comes from the linear layer. I worked very hard to get this to 81%. When I started, this was like 20 or 30%. Then the next one is the min-group gate kernel. This is all of our activation stuff fused into one big kernel. I mean, you can see it's already like, it could be made a little bit faster. You can probably save a few percent off of our inference here, but it's already a 4 nanosecond kernel. But the launch overhead on this machine is even lower than that, right? The launch overhead's only like 2 nanos. I mean, 2 micros, my bad. It's 4 microsecond, 2 microsecond. So sample logits is here, sample logits is very fast, and then this split reduce I need to get rid of. I think this is just from the latest stuff I've been testing. Tricking people into thinking it's good. Thinking it's smart for sure. So again, I'm not using it the way that he uses it for programming though, right? He came on the stream when I was doing the vibe coding thing, right? The vibe coding stream, and he said, oh yeah, this is how I've been using it. And then I'm not using it remotely that way now, right? I'm using it to apply well-defined transformations to existing code. So it basically does not have to think, it just has to template match. It literally just has to do like reasonably, it has to do reasonably accurate template matching is all. So that is very, very different from like, you know, writing a spec and I program in English, right? Dur, harder. Me no like think, right? Jonah, it seems like your kernel is good, and that's actually a very, very valuable contribution. So thank you. I will make sure you are credited for this, and I'm gonna look forward to integrating a bunch of your other kernel stuff. Let me clean up my multi-discrete crap that I've been working on because, as you can see, I kind of have a mess at the moment, and it's making it difficult for me to test your stuff. I think here the last thing I'll show you though is. I wish I could run the train forward past you could see the time, right? Once I get that train thing to work, here actually, maybe I can get this real quick. Software, yeah, Dario's a fucking liar. Like tier list of people I trust at top of AI companies would probably be. Ooh, okay. Demis, Elon. Zuck or Dario? Probably Zuck, even though he's not really doing stuff anymore with this properly. Dario and then Altman. That's probably the list. Well, okay, if Ilya's on that list, uh, Ilya goes straight up to the top. Well, to be fair, I'd have to see what he's doing first, because Demis is also really good. But yeah, I trust Ilya. Ilya's awesome. One of the most brilliant people I've ever spoken with. And that guy was something else. It's actually kind of funny that I have not liked as much based on like what I would think, I should like DeepMind way more than I do. I think it's just that DeepMind, I don't think that they do their engineering correctly. I think if DeepMind actually really got their engineering right and like didn't get so easily sidetracked by like really interesting sounding but not particularly useful algorithmic problems, DeepMind would be top of the top. Yan LeCun, I mean, he's obviously like foundational person in the whole field. I have no idea with Meta. Like, I don't envy his job at Meta. I wouldn't want to have to corral those awful, awful engineers. Um, I mean, he's more out there, but definitely deserves way, way more respect than most of the other people shitting on him. I mean, he'd be way better served if he just, like most of the scientists, which I do myself, if he just stuck to the science and didn't try to like dual purpose all of his platform for politics. That was a really stupid move. Wait, this should not OOM though. He's starting his own startup. I think he kind of got kicked out. But yeah, hey, good luck to him. We definitely do need more people who actually know what they're doing on the science side, trying out their stuff that isn't just the current scale language models hope to do. Commit your changes and roll back. The forward call stuff was working then. Wasn't using that. Yeah, don't worry, man. I think that I'm gonna mess with this a bit. I'll mess with the multi-discrete stuff. Let me fix everything, and then we can start on your other kernels. Do you have other kernels that are like stable that are actively being used? Did you do the mingrew one? Let me see. Fuse scan is used. This one we want to use, but it's broken. And I don't think you have the Mingru one, right? So this is the only kernel that you have that's actively in the main loop right now. This one will get used once we fix the numerics. And then this one will be like, we can port these changes into FuseScan because FuseScan uses this. But it doesn't call it directly. Demis. Yeah, Demis is good. If fine-tuning on real physical rollouts a meme, to deal with somebody real before I spend a month. I don't think it's a meme, but I also don't think it's the best thing to be doing as a small startup. Like, we have, the closest project we have to that, man, is the Puffer Drive project with NYU, where the idea is that the driving companies have some real-world data, but they don't have anywhere near as much as Tesla does. So they want to train a lot in sim, but then also be able to use some real-world data. I personally think that you should be able to get it to work without real-world data, though, just based on sysid. Like implicit sysid from domain randomization. If you're looking for somebody to talk to, though, on drone space that is really, like, they've done a lot, like, Finn and Sam are absolutely crushing it at the moment with the drone stuff. It does work in real. Yeah. Did you see they also have they also got it hovering in Puffer? And it does work in real, it looks like, which is awesome to see. Need to work better? Yeah. I wouldn't just, like, blindly go collecting real-world data, though. I'd spend some time actually, like, analyzing what's wrong and the gap. Oh shit, no way. Yeah. They have they have their drone, because I sent them one, remember? I sent them a crazy fly. Finn is also interning with us for the summer. I mean, he asked and I couldn't say no, right? Is it a really bad move? No, I don't think it's a bad move. Not at all. Real actual limits hardware, sensors, and firmware. Why would that be the limit, dude? Okay, so we still get stupid memory out of memory. Well, let's go fix the dumb sampling stuff, and then we'll come back to this. Well, I want to see people doing stuff out in the open. Honestly, dude, I think this problem is getting crushed. I think we've got sim fast enough now, and we're, like, advancing enough with the core RL loop that this problem is just getting absolutely crushed. From pixels is still hard. Like, you realize why from pixels is hard, man, right? So first of all, yes, you can write a batch renderer. It's actually very impressive to write a good batch renderer, but you still don't have photorealistic training data, right? You've got this massive, massive gap. Which is why, like, state estimation kind of makes sense, because at least then you can fit the data that you see into something that you can reasonably sim and train on. And also, most of the roboticists in this space are just hard trolling, so, like, you can kind of assume that a lot of things can just be way better. You need sensors that are easy to simulate. That I agree with. Yep, that is true. that hardware dude that you order stuff from on Twitter can help, right? Okay, let me now go think of what was the actual test I wanted to run to isolate this. It was running the full multi-discrete sampling, right? The full multi-discrete sampling. Wait, graph actions. Can I keep it like this? Wait, I have apartment exploration solved off of pixels. That's pretty darn good. I have an array of 32 by 13 lane a combinat. Which is like not bad, I think. 32 by 32 is pretty limiting. See, the problem is like, if you want these things to be able to do higher level stuff, they need to have actual images and stuff, which then you either end-to-end it, in which case you spend a crazy amount of money, or you do sysid, right? Ultimately, yeah, probably end-to-end wins, and you end up with like a ton of real-world training data, but we're not doing that shit at the moment, right? We're not doing that shit. And basically, the only people that have an actual incentive to put that amount of money in anyways to do that are the military, so like, whatever. VAE, you can't just like, oh, variational autoencoder at me and like that. What's that supposed to solve, my dude? What is that supposed to solve, my dude? Like, yes, I remember I implemented one of these in PyTorch beta version, or I think actually in TensorFlow 1, when I was 18 or 19 and had a terrible flu in my freshman or I think sophomore fall. It's an old ass architecture. What? Iron dome on the back of a truck. Iron dome on the back of a truck. What? Are you trying to identify military vehicles or something? I'm confused. Fly a drone into an enemy drone. Oh, yeah, that you can probably do. But, like, you can probably do that without even having vision, you know? Though you do kind of need to know which drones are yours and which ones aren't. If it's, if there are lots of them. Alright, where's this stupid thing? Rollout copy call. Here's forward call, right? Just roll out copy call. Yes, right here. Yo, for someone who does not have access to compute, how do I get into RL? PufferLib runs millions of steps per second, even if you don't have compute, and you can rent GPUs for like 9 cents an hour for the really cheap ones, or 30 to 40 cents an hour for the like actually decent ones. So since PufferLib exists, you don't actually need compute. Check out my guides. They're all on X. It's got like a pretty much end-to-end, like step-by-step, this is how you get into RL. The thing I'm trying to do is actually solve. I just need to solve it again because obviously no one has this available. Simulating vision is useful. The batch render simulate things like edge detection, and that will transfer. Yeah, the batch render is just a pain in the ass to make fast, is all. I mean, you can make it decently fast. Have you seen a 10 million step per second RL, my guy? 10 million step per second RL is it's okay. 10 million step per second RL isn't real and it can't hurt you. Except 10 million step per second RL. It's okay. 10 million step per second isn't real. It can't hurt you. 500k, 20x. 500k is still pretty good for rendered. It's tough to make batch rendering fast. But I mean, you know, I got a factor of 20 on you in the speed department here now. So it's like, speed is good. I can train neural MMO faster than 500k now as well. Experiments in lower performance and LiDAR at like 2 million. Yeah. What's SPS on neural MMO? The main policy is 750k. I've hit 3 million with smaller version though. At pixels, I can do that after my experiments. Yeah, that's the thing, man. You need a faster dev loop. You definitely need a faster dev loop. Sweep overnight, yeah. I mean, now you know why RL is hard, right? Like, and why this stuff is so important. Okay. So provided this test is done correctly, This should tell us whether the bug is in sampling or if it's in the backend. I mean, the stuff in Puffer 4 is like, it's pretty nutty. When we've been able to do it, and hey, I'm glad to hear that you're doing well with that, man. Puffer's doing pretty decently as a company as well, especially for the very minimal amount of effort I've put into the business side of it. And the tech is going great, so we're quite happy overall. RL is gonna be huge. I'm not worried about like, oh no, it's open source. People can like make all the money with it. There's plenty to be made. I'm way more curious to see what branches of science can be advanced now. I think we can advance quite a lot of it. Whoops. There's still some core algorithmic problems though that need to be solved. Ooh. Okay. Okay, look at this. This solves. Huh. The bug is actually in the backend logic. $10 mil SPS? Yeah, it's fast. Should I mess around with policy structure? We have had some reports, especially with convs, that conv encoders can be quite limiting depending what you're doing. So I think generally if you have like flat state, for like we have our RMs that have flat state and just have an encoder layer and then some stack of base and then the decoder, that's a pretty solid architecture. But the conv based encoders, you can get some stuff wrong there, yes. This is why as well, the new architecture that we have is way easier to scale. RL will solve stuff like material science. Well, this is how I'm sure that it's going to be important in general. Everybody uses simulation, like it's all over the place, tons and tons of areas of scientific research. It's currently being used as a very primitive tool in which you just guess and check. You essentially just set up the initial conditions, you run the sim and see if the thing happens that you think. RL is going to let us do intelligent sim where we can specify the outcome that we want and then look at the path that was taken to get there. And if we can do that very fast, that makes simulation as a tool a dramatically more powerful one. So it's virtually impossible that we're not going to be able to solve some crazy problems that we couldn't be solved before because of this. So I really don't even have to like care too much about the specifics at the moment. I know that if I just make RL awesome, that we're going to unlock a whole bunch of other problems in other areas of science. Is useful for checking your sim has bugs. Yeah, so that's the funny thing as well. The better our tools get, the more that when it doesn't work, the problem's your sim. It's pretty fun. Also, it does find physics exploits sometimes. We had that happen in Slime Volley the other day. It would like glitch the ball through the wall so the opponent couldn't hit it back. It was a fun one. Size of double. Yeah, mostly looks fine to me. How on earth is this? I wonder if it's in the seats. No, because it has to be in the copy call. You use Claude Code exactly the same way as I do. Dude, the last time you did this, you came into the vibe coding stream when I was just like doing absolute brain dead shit, and you were telling me, oh yeah, this is exactly how I use it. So which one is it? That stream was so frickin' stupid. Did you find it in Vexend? Mismatch in buffer counts? Was there? I mean, this was what it would have to be. It would have to be like some small mismatch, right? Agents per buffer, number actions. Then it stopped impressing me and I had to handhold it. So what I'm doing with it now, Yassine, is I'd say the vast majority of the time I'm using it to execute precisely described transformations to existing code. Like, fold this thing into this other function, or update these signatures with this update, right? Or like, or a larger thing would be like, port this test over to here for this function, matching exactly the way this other test here is written. Stuff like that, where it's pretty much just template matching. So no, I don't really think that these things are smart or good at programming per se, but they are pretty good at template matching. And that makes it a useful tool. And Twitter basically needs to just like shut the fuck up about oh, it's the end of programming, the end of thinking, the end of employment. All the money goes to Sam Altman. Like, shut up. Y'all are dumb. Not seeing an obvious bug. Hypers, num buffers. Hypers.num buffers. Codex is better. What's the Gemini one? Honestly, I might end up doing that because I was kind of just been thinking about of these companies, which one am I the most happy to give money to? More than anything else. Gemini's dog shit? Alright. So we'll wait. We'll give it another gen or two. I think the tier list is like what is it? It's DeepMind, X, uh, Meta. Ooh, actually, is Anthropic at the bottom or second to bottom? I think I like Altman even less than Dario, but I like um OpenAI more than Anthropic. So hard call. Hey Jess. Currently attempting to fix multi-discrete actions. This has no action set to 1. You dummy. Okay, it's doing something. It did something super jank. Let me read this. Because this optimizes. I think the test is wrong. Yeah, I think it screwed. This thing broke the freaking test. Hang on. Multi-discrete's a pain. We also have to do continuous still, which is also annoying. One. Nice job, idiot. Alright, be right back. Yeah, be right back. Let me use the restroom. Let me get a cup of tea, and then we'll figure this out. It's multi-discrete sampling just sucks because it's one of those ops that's incredibly annoying in Torch, and it's actually very easy as a custom kernel. Right back. Yep. Okay. Yeah. Got myself a nice mug of tea. Yes. Okay, this is what we wanted. So the goal is that we test whether the bug is in the sampling op or whether the bug is in training. That's actually pretty easy to figure out, right? I've just kind of gotten distracted a bunch. Hello, Spencer. We had a kernel PR that takes us cleanly above 10 mil. Made the fuse kernel forward about 2 to 3 times faster. And what else? We have multi-discrete in progress, let's say. We have it working on several M's now, but we need multi-discrete to work. Target optimizes instantly with single discrete. We just need multi-discrete. I need to figure out how I'm going to handle all the shared code. One of the projects that I want to have done is I want to have the benchmark for the drive environment, since that one's very high bandwidth. And a full trace. I don't know. In my mind, we just kind of need a stable pre-alpha build to this thing to be done already. Chess update, props to Spencer. Okay, very cool. I can look at one. Wait, made some arch adjustments with great success. Working theory is CNN Stride was screwing with it. That would make sense. Changed to Stride 1, added residual downsampling, made it harder to learn patterns. Yeah, ended with 25% win rate against Maya 1100, which equates to 910 elo. Okay. Really 10 bill because pick phase. That's solid. Okay, that's a real model. You are on the board now. That is a real model. And 20 bill, what's the policy size? Because even if it's inefficient right now, that's not a lot of compute. Can we get the log linear curve for that as well? It would be really cool to have, oh man. What I'd like to have is I'd like to have the alpha 0 or whatever, their compute curve, right? Versus our compute curve. Basically, I want to see if we can get to be as efficient as search on a compute basis. 860K? Yeah, okay. That's small enough. Techniques if the simulation is too complex for an agent to learn. Yeah, that's called curriculum learning, Tim. It exists. We have it. We also have some stuff implicitly on this. We have a fair bit of research in that space, actually. And Puffer 5 is not exactly doing that, but it's going to be implicitly doing that in a way that pretty much solves that problem. let's say. Ugh. Man, I really want to have multi-discrete sampling working today. I want to have several new environments bound, maybe continuous, we'll see. I'd like to have the kernel working for this as well. Okay, this one breaks, right? So if this one breaks, how do we... Let me think what we can do from here. Believe in you. Yes, okay. I kind of, when I stream, the amount of time that I lose talking to chat is not more than the amount of time I would lose getting distracted by other stuff if I were not streaming. So, I much more enjoy working this way. I like having like really long stream days and then having a few days where it's like more chill. Elon's well, because he is, but he does get stuff done, and I don't believe he's. I think he actually has good intentions, is the thing. Like, I don't believe Dario or Altman actually have good intentions at all, or Zuck for that matter. But I mean, Zuck just wants to make some money, so that's fine. Hey, Robbins. So this should isolate it to just the board pass. Yeah, I don't make any political commentary on this stream, man. I only talk about things that are direct AI. And my read of it from his bio versus like the other information I know about the other people running stuff is I don't think he is actively trying to make something that is bad for like, a bad outcome for AI at the very least. Hey, Cloud Surfer. That said, I don't think I would touch the Jax TypeScript Rust stack that they're using at X with a 10-foot pole, but okay, we're not optimizing. We're not optimizing. Cool. 14 logits. Discrete. Wait, what? You can't skip train forward call, you idiot. Yeah, you can't do this. Oh, okay. Hang on. I have to think about this test a little more. Intentions are good. Yeah. I mean, I would like, I think humanity is going to change dramatically with AI, but I hope it's a way, it is in a way that puts us in a better position, you know? I'd like to see people become smarter, more capable, more able to think and reason clearly because of AI, not the opposite. Let me think, what do we do? Can I handle this? It's kind of difficult to test both. I can't skip training. Knowledge and humility. Knowledge, yes. Humility, I don't consider to be a positive trait. Humanity should be awesome and be proud about it. I don't know why I didn't try this from the start. So basically we just try the multi-discrete sampling logic, but with a single head. And we see what that does. Ah. Hmm. I don't know. Okay, this does train. You see, this does train. I need that length. Let me make sure this is good. Yeah, so this does train. Hmm. Yeah, I'm using it. Not like the first stream, though, my guy. Okay, I suppose we also have... for target to multi-discrete. No, that's bad. Just copying. So, Civ, I'm not using it remotely how people were telling me to use it, is the thing. Like, the vast majority of my uses of this are to apply well-described transformations to chunks of existing code. Pretty much every single recommendation that people were giving me was about giving up more control to the AI and thinking less, and I'm not doing that. Okay, we know it works for single variables, even in this path. Is it something with this sum logic? Could be something with the sum logic. But I'm pretty sure this is how we want it to be, right? You store actions. And then in training, you call sample logics. I see, yeah. Like, my view is that you should be able to be using these tools to think more and to do more, right? You should not be using them to think less and to slowly be replacing your ability to learn to the point that the tool is just doing everything and you have zero value add whatsoever on top of it and you have no idea what's going on. So in that first stream that I did, right, as a test, because people asked me to, I had absolutely no idea what the hell was going on. I could have done everything on that stream blackout drunk. This project, the way I'm working on things now, I have to be every single bit as focused and attentive as before. And I'm actually thinking about pretty much the same things. I'm just not getting interrupted every 10 minutes by having to like go track down 8 places in the code to manually update function signatures, because in this specific project, there's a ton of redundancy because there are 4 different languages involved and like a few different external libraries and things to deal with that all have their own nuances. Very boilerplate, very easy to validate. It's not so much it's boilerplate, it's like it's very templatey is what I'd say, right? Like we have a bunch of things where the code is very, very well described. And a lot of the operations are like, take this chunk of code that looks like this other chunk of code, and then convert it to this other form, just like we converted this other chunk to that form over here, right? That's more what it is. See, like this is a reversion. This change. That's nothing. I can occasionally use it to like check for like very small details that are easy to miss. I'm pretty sure that sum is correct though. So it trained before, now it doesn't train, right? Yeah, so this does not train. I do have kernels on. It's interesting. Make sure it doesn't work all of a sudden here. It still doesn't work here. Something with the buffer. It would have to be something with the buffer, no? Because see, this code's a direct port. Like this is a direct port of handwritten code from PyTorch to libtorch. And there's probably some very subtle little thing here. I suppose we could try without the pad sequence. Could try without the pad sequence, actually. I'm going to do that next. I'm going to try without the pad sequence next. If this doesn't find it, what I'll do is I'll just do this code in a loop. And if that doesn't work, then it's something with the buffers. Right? Because, like, what the heck else could it be? Hmm. Yeah. I think next operation will just be we do this in a loop here. That actually might be better anyways, to be fair. Because this is literally just the fallback implementation anyways, right? So why do we need to have this just like this massive mess where we introduce two different pathways, right? Did we sample the wrong order? I think that this is because the buffers are stored different shapes, so I don't actually think this is it. Yeah. It's okay. Basically, within a few minutes, we'll have... This will give us a guaranteed stable way to do it regardless. The next thing. So, I think we have, yeah, we won't be stuck on this all day. It'll be fine. And then after this, we will be able to do... Well, target will work. We can probably bind a couple other ends to this to double check. Maybe we'll be able to do drive. I think I should be able to do drive. It would be so cool to have the driving end working with this. It's like a really chonky end. You know? Yeah, so I'll let this try, and then I think I'll just like do this but in loop. Yeah. And then actually that won't even be slower because if it gets graphed, no, there's one additional split op, I suppose. Yeah. That's still fine. One additional split op. Yeah, it would be fine. Fix I made to forward call should be sufficient. Okay, let's see if that runs. I think that is the layout's different. It did actually figure out that the layout is intentionally different. Yeah, no, right? Doesn't work. No? Yeah, this will be better. Because otherwise, man, this multi-discrete logic is just bullshit. It's so much easier to just do this in a kernel. Yeah, right, like this. Of course, it's completely stupid that it's done this, because, like, that's not graphable, dummy. But we can start with it. Graphing off. Yeah. Does this train? This trains. Literally just the stupid legacy torch. Cool, that actually trains. Okay. Get rid of the zeros. Cool. Rebuild, and now we can actually test our frickin' kernels. Will be good. And I suspect that the backwards version is like crazy redundant, right? Yep, trains. Well, does it still train? Oh yeah, look at that. Trains very nicely. Good. Multi-discrete working is quite important. And actually, if we manage to now have a way better kernel for this, that actually will make it way better to have your environment as multi-discrete than it used to be. Because it used to be that you'd write multi-discrete M's and stuff would just be slow. So there was actually kind of an incentive to make your M single discrete more often than you would really need to. So Custom kernels for the win. Ooh, that is super good. Look at that. Perfect. Okay. Now forward call is fine, right? Forward call is fine. Custom kernel is fine. It is a little bit annoying, I suppose, that the PPO loss backwards has this stuff in it now, but presumably this should not be bad at the moment. Like if I just do this, we're still 10 mil. Yeah, we're still 10 mil plus. Good. This is a good time to make a clean commit. Okay. We're happy, yes? Now, for the driving environment. So, what are we going to do about this? This load map shenanigans is like, whatever, we can figure this out. It's on step though, man. Yeah, it just remakes the damn env every time, doesn't it? If we ignore resampling though, right? Let's say we ignore resampling for now, because that's gonna just suck. What do we actually need? We just need the shared method, right? The shared method passes some crap back. Okay, let me think about how this makes what makes sense for this. This also has variable num agents. Yikes. And that's why you need to know as well. It's no different now, right? No, it's no different now. Where's this code live? Doesn't live in Python, that's for damn sure. Live in the C++. No, I think that this code lives in the binding. Right. I think all this will just live in the C binding code. I need a few minutes to think about this, and I gotta use the restroom, walk around a bit, grab some tea. I'll be back in a few minutes. What we're gonna try to do is get the driving env working with Puffer. Not the custom reset metric method yet, but I think we're gonna just move a lot of this into the C layer. I'll be back. Let me grab a cup of tea and I'll be back in a sec. All right. Wow. Moving too slow today. Let's get going. So, I think what we're gonna do, I think most of this stuff is just gonna get moved into the binding code. I think that's the play. Because otherwise, with this shared init stuff, it's like, it's really weird and janky, right? Yeah. I think what we can do, is this too big for Claude? I think I can describe this as a precise transformation, though. I need to get it clear in my head, though, first. Got infinite and vec init. Yeah, so what we're gonna do, but this calls that, right? Yeah, my init. You create the enums. Screws with the block sizes, though, doesn't it? Maybe we should do the block sizes first. Yeah, okay. So there are two problems here, right? So first of all is that the drive env has this like wonky shared init thing that needs to get ported now because I haven't thought about how to do that. And the second issue is variable number of agents, in the sense that different environments have a static but different number of agents. Because that's going to screw with the way we do blocks, isn't it? Oh, actually, no, it's not. It's not going to screw with the way we do blocks. Because we will simply have, it could be a little inefficient at times, but it's not going to break it. Google came out with a new algorithm called smart sampling. Smart independent set. Smart. Wait, sampling what, Jess? Like, what do you mean? Calls my init, right? Vargs. Yeah, because it's doing the init loop for them. Data sets for ML tasks, less data. Data sets for ML tasks. Oh. Huh. What's it based on though? Like that, like it would be a replacement for a prioritized replay, right? Okay. Yeah, I think we can do this as a series of precise ops, actually. It's not that hard. Like this, right? Cool, this still works. Skimming currently. Cool, cool. I am doing right now variable num agents for 4.0. Or at least like how we had it before, where you could have different numbers of agents in each env. That's good. And now vec m star. Do we have agents? Oh, it does have num agents. Do we do total agents then? Wait, how do we do that? That's super jank. That's super jank. Simple close. Yeah, this is all it is. I just have neovim and like a pretty minimal neovim. How are we gonna handle this? Env num agents. Okay, maybe we don't make it a required param. The buffer's always the same. The buffers are always the same, right? The blocks can be different, but the buffers are the same. Let me think if I know the exact. Buffers. Buffer is always the same. Yeah, for folks watching, if you want to help me out for absolutely free, just start the repo. It's all open source. HyperFRL. Almost to 5K, and I've been slacking on promos a little bit. Almost to 5K. Okay, I need to actually stay focused here because this is... It's gonna have to pre-compute. It'll just do an additional loop over the ends, right? Yes. This is what we want. So each buffer needs to know how many agents it's allocated. right? Mm. Yep, that's annoying, right? There's no way around this. I'm pretty sure at least there's no way around this. You end up with a bunch of gross non-contiguous copies if you do it any other way. They are static when graphed, which is fine. I forgot that we have to do this. Do I need to allow this? No, hang on. I don't want to allow this. This is bad. Is it? Yes, it's bad. Right? Oh, it's hard to tell, actually. Okay, let me think about this. Let me think about this. We can simplify this if we assume that each buffer has the same number of agents. How much harder is, how much worse is it if I don't do that? You end up with a few additional memory buffers for graphing. The main thing is with their reset mechanism, like they screw it up every reset, which is bad. I think we just do the masking thing. Right, we just do the masking thing. Yes. Okay. Buffers will have the same number of agents. M's will have different numbers of agents. That'll be simpler. Yes. I'm actually thinking that probably we can end up with a cleaner form of this whole thing. I'm seeing like several places we can make this a lot simpler. Okay. That's fine. Because it's like, you know, feature, 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 up, too much complexity, crunch, 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 feature, 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 up, too much crunch, right? Total agents, cool. So then what we're going to have to do essentially is just the init. Actually, that makes it very easy, doesn't it? Oh, no, we still need to have the, do we have to have the block starts and ends? We might actually, I think we still need to have the block starts and ends, but over end, like we need to know which ends belong to which block. Hmm. That's fine. Don't we need to specify block sizes now? Do we split up num agents into a specific number of buffers? Let me think about that. Specify total agents, I suppose. As a train param. It's an env param though. We can specify it as a vec param. Yeah, we can specify it as a vec param. Let's look at this. Total agents. Right now it's coming from here. Do we need to know the current buffer agents? Okay. Yeah, that'll be better. So vec just specifies total agents. And we can easily refactor. No, this will be way better. Yeah, this will be way better. Okay, so you get your vec args, you get your nvargs, total agents. It's distracting in the background. Okay. Slot times op size. Oh. Copy mask on init, that's good. Then all the SIGs gotta get updated. Numems, buffers, all this stuff will get moved in. This will end up just being 3 args. It'll be vec args, env args, and then use GPU or whatever. It's fine. It's fine for now, not really great. I mostly just want to have I want to have a sense of what this is going to look like. I think it's going to be pretty much fine. And then it just basically, it puts the onus on you to do your initialization correctly, but it's way easier than it used to be. It's fine. So with this is nice. The only thing that we'll have to change is the env loop, right? I mean, the work blocks get screwy. I think the work blocks are going to get screwy, right? Yeah, because we have like the block specified as a number of environments. ends. I forgot about this chunk. This one's way harder. I'm still worried about the vector like block filling thing. I think it'll be okay. We'll do this to start as a test. Okay. If this doesn't work, we'll test it with the original config of 8s. Yeah, that's much better. I think it'll just end up being vec agents and buffers as well. Be way cleaner. Cleaner, simpler. Yeah. It'll be vec agents, vec buffers. That'll be nice and easy. Because like otherwise when you would have to do the math before as well. Yeah, this is the general and simple thing. So if you have a really screwy distribution of m's, the work sizes is going to be weird. So we'll have to come up with what that param will be called in Vec, because you're going to have to be able to tweak it, I imagine. That can't just be fully autoed. Yeah, it's better. Honestly, my goal for Puffer 4, if we can get the code to a point that I'm no longer tempted to do so much of this with Claude because it's actually pretty succinct and simple, that will be good. Right now, there's just too much crap and things are too disorganized. I think we can make the VEC substantially simpler. If we only support one D-type, we can make the kernel simpler and therefore the binding simpler. I think that will also simplify our headers. So at the very least, we should be able to strip out like a couple thousand lines of garbage. We'll see. Yeah, the block sizes are going to be a mess here, but this should be pretty simple to test. We should be able to have this working pretty quick. And then the only thing we'll be missing for drive-env is the shared init stuff, which I think we can do pretty quickly. I think we can do that part pretty quickly. Big. Oh, hey Jonah. Seeing 17% speed up in log coefficient values, 4% on backwards. Ops, they're not equal. So if you've made the log coefs and values 17% faster, Jonah, then you should be able to fold that into fuse scan, right? So the log coefs and values kernel is an isolated test that is a chunk of fuse scan. Same with log cum sum exp. The fuse scan is a very big kernel. It has both log cum sum exp and then log coefs and values, which uses log cum sum exp. So pretty much all the overhead from custom ops, other than the PPO kernel, which is just like not numerically correct at the moment, but all the other overhead is in that fuse scan op. So if you've made an improvement to log coefs and values, then you should be able to fold that into the fuse scan and see that be faster as well. So that's how you can test. I got the multi-discrete working. I still have a big mess here, but I'm working through. 17% on log coefs and values would help quite a bit, I would imagine, with fuse scan. It's fine. It's messing with the configs a little bit too much, but that's fine for now. If we can get it to work with variable num agents, it's fine. I have it overridden anyways. This one's already done. It's done num buffers, that's fine. We'll cast it back. Segfault's lovely. Yep. Oh yeah, it trains. Ooh, it trains. Very good. And it has too few agents, right? Because it's supposed to be like this, right? And then this goes to 10 mil. Perfect. Okay, we got it. Here's the restroom. I'll be back in a sec. Maybe, wait, changing the ops themselves does nothing to the checkpoint infuse scan. Really? That's weird. Is it still memory band? Is it like still bandwidth bound? I thought that the ops were pretty expensive. Like, that's not a super fast kernel, right? I mean, there are all sorts of things you can play with if you'd like. I need to have I need to fix the PPO loss kernel for sure. Probably want to play with BF16. I think the PPO loss kernel would be super nice though, because that's pretty much just like a guaranteed little perf bump. And you know, also it's like annoying with multi-discrete and stuff because now everything's going through this for loop with multi-discrete. There's just a ton of these stupid little kernels in there. It'd be way cleaner to have them nicely merged. I don't think it's like crazy slow. Look at the PPO stuff. Cool. Thank you. I'm going to figure out the vecm stuff right now so that we can have variable numbers of agents in the EMS training, and then hopefully if I get the shared init stuff, I'll have the driving env working. So we'll have some new environments to test against. Yeah, that's the plan for right now, and then I'll be back to kernel stuff, I think, after. I am a bit curious if we do, like, all BF16 activations. If that's, like, if that's reasonably stable. It could be. Not sure. There are definitely some points we need to do, like, we need to do better on stability, though. Okay, so this sec faults. Hmm. Block size in here. Where's our block size? Buffers. And create threads. So let's just do block size. Let's do this real quick. Yeah? If this works, it's probably just overrunning. No, it doesn't work. Interesting. Yeah, M's per buffer is screwed up. Yeah, that's definitely what it is. Okay. So this will work. We'll get this to work, and then what about for shared stuff? I think we'll pretty much just have to like do that my init function, but for the more complicated drive engine will be good, honestly. It's not that bad. Yeah, the wrong env iteration, that's it. Yes, spec count. What is this? Look forward to dreading. What snow, Jess? I'm in Florida. I see. It can definitely mess this up if I'm not careful. Let me look at this. So the way this is supposed to work, you've completed a specific number of buffers. Can't handle on Sunday. That's about it. Yeah. No, I'm chilling. I'll be back to Maryland once it warms up a bit. I like it there anyways. I get way more work done. Family, Jess. Yep. I think this is correct. I mean, it'll be very quick to check this. I'll run their freaking commands. Still seg faults. Okay, so breakout trains. Don't worry about the speed. That's the block size of our VEC. Is it stable? Oh, geez. Is it like a little bit off? Uh-oh. Yeah, that's janky. Yeah, that's definitely wrong. Okay, we'll try this one. Wait. Okay. This should fully solve. Yes, right? Okay, that one is correct for breakout. It's finished. Wasn't that like relatively recently started? 24 M's. I mean, we can set, here. If I build this one, if I do this, okay, you can't do that. Well, yeah. We're not gonna get a clean debug build out of this stupid thing at this point, are we? Okay. Anything what else I can do? I voted 5-coded Flappy Bird, but it only transits 90k SPS. Well, I'm not gonna help you with a thing that you just vibe coded, my guy. That thing's like 150 lines of code, including all the binding stuff. You should not need to vibe code that. Defeats the point of the exercise. Okay, so we're segfaulting in compute obs, which is in the reset. What's the expected SPS on a good GPU? Like a couple million at least. Could be 90 on a CPU. Oh, wait, if it's resetting on this, On compute obs. Okay, I know. Then hang on. Let's take a look here. Total agents times ob size, right? That looks suspicious, right? Oh, that's why. Yep. That's like, I can't believe it missed that. That's so stupid. It really didn't pair that alone. Yeah. Yeah, I don't like this. It's kind of fine, right? I like this. 3 minutes delayed. Yeah, YouTube does that sometimes. People like, oh, it's 10 minutes of lag, and they're just scrolled back 10 minutes. And then this is the target one. This is fine. Remove num m's, which is good. And this is possibly variable number agent support. Possibly done. Or at least drafted done. GDB. Hopefully not, unless we segfault still. Yeah, we do. God damn it. Man, how are we still gonna segfault and reset? Like, really? I mean, it looks like we do. Well, what was the point of that? What is crit? Like, you're not gonna learn anything doing that, obviously. Do learn the code. Do you think I can ask the coding agent in command line do learn the code? The fuck? My guy. Are you, outsourcing a bit too much to learn the code? Oh. Well, no, why the hell would you do that? I mean, dude, like, literally think about this for 5 seconds, right? We have an entire library of actually well-written environments that work and that are clean, right? That you can go read through. Or you can have the agent vibe code a shitty end that doesn't even work correctly, and then ask the agent that just vibe coded a broken env to explain to you how to do stuff based on its broken env. How does that make any sense? Like, literally, just go read the guide that I put together, man. We have several sample envs. It's more than enough from there to be able to have, like, written a good version of that, like, Flappy Bird env. And you should be able to do it in, like, not 5 minutes, but within a few hours. What do we think about this? Weird, right? Total agents. 24 M's. Okay. Okay, so vec size is what it is, right? Ah. Whale. Because you're not assigning memory, are you? And how is this supposed to work? Why is this agents per buffer in here? I'm actually surprised this thing is so dumb. Oh wait, do we have buff agent? No, that's actually okay. Did it a little weird, but These look fine to me. Do we get the address maybe? Why is my freaking thing not, why's my autocomplete not going? Super annoying. Okay, so this thing breaks on agent 255. Interesting. Four. Oh. Hang on, I'm dumb. I am very dumb. Yeah, yeah, this is why. Okay, well, oops. Plus plus. So subtract 16 from this, right? Seem right? Okay, it trains. Like, should we just train it fully? Yep. Oh. Interesting. This is like way too many agents for this stupid little end, though. Are you in the cleaning up phase? Well, we're binding other environments, so there's still some stuff that needs to get added in, but most of what we have to do is cleaning up. Yeah, there's still a lot of cleaning up. Okay, this will be sufficient for testing. $53. That looks good to me. That's stable training with variable num agents for sure. Yeah, so this one is not set up for that, so whatever. Corrupted size. Really? Ah. What was it before? 28? There. Still? Really? Corrupted size versus previous size. Num agents. There's no way. Oh, you dummy. Yeah, there we go. Nice. Speed up is 4x for both. That's good. Very good. I forget if the PPO loss kernel was all doubles or not. I had not even gotten it working numerically yet, is what I remembered. Testing now. Do you have it? Wait, do you have the numerics matching? Hang on. Copy, pasted. Where's it? It's in the Discord, presumably. I don't see it in the... Did you put it in Discord? Or is it a... Is it just... Did you update the PR or what? Hey, Junker. New PR base for this? Okay, let me commit this. One sec. Okay. Perfect. We've got variable num agent support. What time is it? It's 2? Oh, great. We still have plenty of time. I've only been live for 5 hours. This has been a short stream so far. Yeah, so what we're going to do, let me use the restroom real quick. Let me grab some tea. I'm going to take a look at Jonah's new kernel, give him a little bit of guidance, and then we'll see if I can get the shared init stuff for the drive end working, because it'd be really cool to have that one bound and tested, and we'll see how long that takes. I'll be back. Okay. I gotta send one message, and we will get looking. Oops, I missed some messages. One sec. So Junkart, yeah, my best advice. It's probably gonna take you a while before you can like understand all the stuff I say here, but all my best advice. There's the programming and ML guide right here. This is probably my most viewed piece of content. It doesn't have a step-by-step guide on how to learn programming, but it has all my best advice. And then for RL specifically, there's this one. But I think that this will give you a nice starting point and prevent you from wasting a lot of time. What's this? Oh, cursor tab. Honestly, the only model I have that I really, really like for in editor right now is the Super Maven model. Because it's just ridiculously fast. Let me go click Jonah's PR. Alright, what do we got here, man? How do you efficiently learn to program? Been lost. So, you do projects, man. That's what you do. You start with really basic, simple little projects that you write entirely yourself. So you do the end-to-end, the whole thing. Do something that's like you can do in 50 lines of code if you're brand new, or less. Work your way up to projects that are a few hundred lines of code. You can do a lot in a few hundred lines of code. And after a few months, maybe you're ready to work on something that's close to 1,000 lines. But all my best advice is in that article on like things not to do and things not to waste your time on. It's going to be about 80% just doing and maybe 20% formal resources. Like obviously you need to know the basics of syntax. But the actual toolkit of things that you need to know to be effective is very small, and the skill required to use them well, is very high. Let's say. FP32. Original FP32. Okay. It's better than Super Maven. I don't see Super Maven on here. It would be nice to have a local model that I can run, though. They don't have the prediction latency on this thing. Oh, under 500 ms. Yeah, okay, so 500 ms is crap. On laptop and under 500 ms, though. Yeah, they need to have this thing benchmarked properly. So the thing is, Super Maven. Yeah, it was like 250. And honestly, even that, like, it would be much better if it were faster. Cache action logit. Ooh, you do block losses as well. Oh wait, no, this was this there? 500 ms on a laptop. Presumably a GPU laptop. I mean, I can try it if it's a local model. That looks cool. Eventually, Super Maven will get, like, Cursor will stop supporting it. New PR to Discord? Is this what I just did? Ooh. Online softmax in both. There's no correctness check on this though yet, right, Jonah? So there is a correctness check that was not fully passing in, if you look in test/microbench. Yeah, so if you have it like this will be super good. Yeah, if it's this fast, then there's no need to make it faster than this. Like 3 microseconds is gonna be, that's amazing. Like, perfect. And it should be that fast. It's not an expensive operation at all. It's just a loss function. The backwards being that fast is very nice. You can see the torch ops, though, are like, meh. It does get substantially better when you graph it. But, like, still, 49 micros I'd rather just not have exist. Plus, this will make it better when... This will be way better as well for training with, if you have to disable coup de graph for whatever reason, the non-graphed path will be way nicer. 20 to 30 tokens per second. Eh. That's probably nice to have. I'd have to put it on a container is the thing. How much RAM how much ooh, but we probably wouldn't want to put it on the GPU, right? Cuz like if we put it on the GPU, then we're going to be eating into the RAM of the RAM we have for training. So I guess if it's the half bill model, like the 500 mil model, that's what? Are they float weights or are they quantized? It's only a couple of gigs, it's not bad. I don't know how much RAM it takes. What would you like me to do with this, Jonah? Like, the speed's great. We need this to pass numerics checks. And yes, I know that the original did not pass numerics checks. Wait, check pointed forward. Oh yeah, fuse scan, yeah. Check Discord messages get eaten. My bad. Added to profile kernel now the correctness. Wait, it's added to profile kernel now the correctness. But then wait. I don't see the I don't see the correctness check on here. Like, do you have a passing check? I'm looking at Discord now. Profile kernel has the correctness in it. Ooh. So the original versus PyTorch did not work. I suppose we can check now. Okay. What is this editing? Profile kernels, CUDA kernels, vecenv. Maybe I just go merge. Maybe we merge this. I think I'm gonna merge this and play with it. Since I have you here. We'll see how... Oh, it does. This merges cleanly somehow. Gotta jump in like an hour. Okay. Let me see if I can get your kernel to run. So this is how we currently are on Breakout with no kernels. What is this? Actually, let's do like this. Kernels, coup de grace, right? Why are we at 3 million SPS? I'm confused. What the heck is what's going on here? Good for research. Yep. Yeah. So CleanRL is very simple. It's, I mean, my favorite thing out there, and a lot of the inspiration for Puffer. The speed difference with Puffer though is just like it's more than 1000x at this point for a lot of stuff. Which of these do I keep? Presumably this is the one that I included, so we'll use yours. I think yours, it's the same though. Yep. Okay. I think your merge might have included. Yeah, I did. And wrappers. Yep. Okay, so this is our original speed, right? And now this trains in like 12 seconds. We have this one commented because it wasn't stable, right? Oh, stupid Claude took it out. Stupid Claude. It's like, oh, this pathway is like not being used. Let me remove this, even though it's obviously commented for use later. What I mean by it being like super redundant to add it in places. Okay. So our original kernel here. We'll check the original kernel and then we'll check yours. Syncloud now. Yeah, I'm using it for, I mean, you see what I'm using it for. Right? Mostly just using it to apply well-defined transformations to existing code. Okay, so this completely breaks learning. We can see this, right? The loss completely breaks learning with this one. We'll try your optimized one. Presumably this doesn't have module bindings. So copy. What did you call it? The new PPO loss? So I mean, this is like a well-described transformation. There's no ambiguity of what the code is going to look like for this, right? It just needs to go update redundant stuff in like 5 places. Numbers you always look out for besides SPS on what, Liberty? Yeah, so this needs these launch configs. Actually, shouldn't these have been there already? To be determined. These, I hate all these launch sigs as well. We're gonna probably end up doing, we'll see if we can end up just deleting all these ones. Differences in kernels. Oh, well, I mean, we have NSYS for, NSYS tells us exactly how many microseconds, we're spending in each kernel. And then there's a correctness check, right? And then sometimes the correctness check can pass, but training can fail. So then we also make sure training still works. Yeah, so like this looks like it's adding a huge chunk of code, right? But this is literally just copy pasting and changing the names. Okay. It computes on the fly. Cool. So presumably this somehow is passing numerics checks, but is still not going to learn. I think this does need to be zeroed. Kernel overwrites. Ooh. Okay. Yeah, because it's a catastrophic failure, right? Oh, wait. Hey, your version learns, dude. At least it learns a little bit. Okay. So let's go see what your thing is. Loss output. This thing, launch PPO forward. Kernel overwrites. Okay. Can you even do this? Because, wait, loss. Let's try this. Simplified 20. Wait, what do you mean simplified? Fixed reset. What has been simplified, Kyung? Because we have, I got it bound to Puffer 4, so we can actually try some stuff pretty soon. I'm fixing one kernel here with Jonah. But we should be able to have like some fast Puffer 4 test on 2048. Wait, oh, did I do the wrong one? Oh, I'm dumb. I did the wrong one. My bad. 6. 623. This one, right? OBS reward curriculum. Like he suggested. Interesting. I will have to look at it with you in a moment. Let me get the... Let me see if we have this kernel working. Oh. It's faster, but this still doesn't work, man. Where's this check that we have? It's make a PR to 4.0. Awesome. That will help. Do saved for backward. Saved for backward also gets empty. Is that getting accumulated or just written to? Testing against just breakout, man. So breakout should be an easy solve. There. How's this breaking now? Oh. Yeah, that's annoying. It got all the way up to 10.9 towards the end of training, by the way. So if we can make this thing stable, that's pretty awesome. Oops. Okay, you added a whole bunch of counts for this. Good. Original versus optimize, original versus PyTorch, optimize versus PyTorch, mean abs diff tiny. Anyone code AI in this joint? My dude, this is the development of the highest performance reinforcement learning library streamed live several times a week for many, many hours. How do you pass that kernel's variable back into that function? I don't see a kernel's variable through, though, in train imp in PufferLib. Should I just commit this, or no, you're on a fork, right? Well, you can still pull it. Here. Yep, I got you. Okay, there's your commit. CUDA. Wait, is this? Yeah, this is zeros. Here, I'll do zeros. Zeros messes up, zeros launches extra kernels, by the way. Empty does not launch extra kernels, but zeroing launches an extra kernel, which is why it's better to fuse it if you can. I have no idea why zeroing launches an extra kernel as well, because like they could just do CUDA does have a memset, right? They could totally do that without launching a frickin' kernel. Can add that. Yeah, we can totally do it in the kernel itself, man. Let's get it stable and then we can do that. If we get this stable today, though, that'll be so nice, because I've been wanting this kernel to just frickin' work for so long. And it's been passing the numerics check. I don't know what's wrong with it. I mean, as you can see here, though, something's wrong with it. Please do numerics check. Add values. Here you're zeroing your losses. Wait, what's this get? Do we get Arg's torch? Okay, so I mean these have reasonable coefficients here. I was concerned if you had 0 ent coefficient, for instance. But these look fine. Loss value. I'm worried, like, is the check just not scaled correctly? Because sometimes, like, the checks can be such that they're just massively scaling down error. What's the command to run breakout? So once you've rebuilt, then it's just this. Python, sgem, PufferLib, PufferL train, puffer breakout. You have to rebuild both. So you do scripts build vec breakout like this, scripts build vec sh breakout, and then you do the setup as well. Forge dash dash in place dash dash force like this, yeah. Go to that photographs real quick. Okay, so without coup de graft, same result. So it's not coup de graft screwing it up. Hmm. Where's the original one come from? Wait, how on earth is this one valid? Use PPO loss C++. Okay, so this is the I just want to see what happens if I do this, if it actually screws up the profile as expected. Well, the C++ one is basically, like that's copied from the other file. I do suppose it's possible they're out of sync, though. Like maybe we're not copying the outputs or some weird thing correctly. But it does learn, right? It learns mostly. It seems numerical because it learns quite a bit, and then it like crashes or tops out or whatever. You know? Maybe it's a learning rate thing. Well, they should have the same learning rate, so unless there's some dumb thing going on. So this should mismatch now, right? When I do the correctness check, it should totally mismatch. Okay, so if I do this, I get original versus torch. Wait. Okay, the original and the optimized match, and then the torch ones mismatch if I do this. So this is the expected behavior. But literally just multiplying this arg by 2, I only get a mismatch on the order of 1e minus 2. So like, I'm wondering if it needs to be way smaller. I'm gonna try this real quick to see if it reveals anything, and then I might just hand this to you to see if you can figure this one out, if that's all right. Because it's like the kernel is so close. I'll take one more look though, actually, at the calling code just to make sure I don't have anything wrong there. Good to try to figure it out. That would be very helpful. Because like stable PPO loss kernel. First of all, if any of our users run the thing right now with CUDA graphs on it, with CUDA graphs disabled, the loss is ridiculously slow in normal torch. So it'll just up our overall usability a ton. But then also even without that, we still lose a little bit of perf to not having everything fused here. Just kind of silly. Because I think with this one, with this kernel, we'll be close to 11 mil SPS. And we'll also have cleaned up the line profiler a ton, which is always good. Yeah, it's very close. Weird. Let's just check the calling code real quick for you. Because, I don't want to mess it up for that dumb reason. I don't see any copies in here. Is it this? This thing? Graph MB ratio copy? Mine seems to learn. Wait. That's the correct score. Is it built using the custom kernels and everything? Like you have kernels, if you check you need kernels true here. Oh, I'm not sure where's that. PufferLib, PufferL. Line 157-ish. Kernels true, right here. PufferLib, PufferL 157. Let me make sure I didn't forget this thing. So we have ratio new and value new, right? Is this not getting updated? If this is not getting updated, this would do it here. So it might just be this. I don't see where this would be getting updated. It could be this. Let me see if I can get this to roll it into the kernel call. Wait, MB ratio. How's this get updated? I'm confused. I think that this one does actually matter a lot. I think this is probably it. Wait, graph? I think that it's not, like, these buffers are not getting updated. I remember these being important. It's like this quirk of, it's a quirk of the Puffer PPO implementation that seems to be quite crucial. Here, it's trivial for this thing to just fold it into the kernel. Let me see if that fixes it. It'll probably incur some buffer overhead. It's literally a copy. I'd be shocked if it screws up folding it into the kernel. If this works, then I can fuse the zeros call, like the zeroing calls in, and we'll be set. Fold 2 lines into kernel has to change things in 10 places. C++, header, modules, launch, kernel. Yes. Let's see if this does anything. Still want to zero the loss? Yes. It was better. Put it into the right one. Optimize. Yeah, it did. Set. Yeah, that would do it as well. Not coup de grace either. We can go check what happens to see if it's a comparable effect, right? Like if I just comment these two lines, what happens? Reran again and you hit 850? Really? You... Huh. Both forward and backward. Okay, maybe I missed it in backward. Hang on. Let me go double check. If you're getting it, then that's perfect. Okay, apparently it's supposed to work even without this. Weird. Wait, CUDA memset async. To the launch function, right? Like right here, right? What would this be? Grad loss? No, you wouldn't want this now. Where would this go? Wait, what are we zeroing? Grad loss? Well, this is const. What are you zeroing in the backwards? Wait, what are you zeroing in the backwards? This? Okay. Let's see. I see. I thought I did that though, and it didn't make a difference. Huh. Why did it not work? Wait, is it with kernels on? Kernels are off though. So wait, with kernels on. Yeah, no. Wait, what? Is it better? It's still not working. Do you have kernels on? I'm confused. Yeah, you have it then. And you did rebuild this thing. I mean, regardless. Oh, do you have the if false on here? Can you check? There was like an if false around the kernels thing before. If you check the extension. Because it wasn't working before. Can you make sure that this thing here, this is like if kernels, you don't have if false on it? Like make sure it's actually rebuilt the version of it, you know, that you rebuilt. You run setup.py build torch. And if that learns, then I need to see what you have, because if you have it working, yay, we're set. Okay, so that's the correct thing. Can you run the setup, which is Python setup.py build torch in place force? Can you run this? Okay, you did do that. Alright, did I break it then with the kernel update thing that I did? I'm confused. Only thing I can think is we comment this crap. Nope. Gotta jump in a minute, can go through branch. Yeah, that would be great. If you can get this thing working, like, that's awesome. I think I'm gonna go do the drive end for a bit. And if you get this working, that'd be great. Like, because this kernel would be very nice to have. It's a pretty decent speed bump. Tomorrow or early next week? Sounds good to me. Thank you. Okay, this is without that kernel. Still 10 mil. Yeah, I think it's like maybe an extra 4 to 600,000 steps per second that other kernel would add, which would be nice. I'm using the restroom real quick, and then we're gonna figure out the drive environment. Let me mentally reset. Okay. Let's figure out the drive end. Okay, so we need to download the binaries for this thing, right? Maybe on here somewhere. Nope. Oops. What's the command for this? 2048 to 40. Simplified but reliably reaches 65K. Grid only obs. Heuristic. Okay. See this run. $6 bill. Okay. That's that is good. I want to see the policy for sure. What we got here. So you flatten. Okay, it's just a sequential encoder. Right? Oh wait, position embedding? Mine's a little different though, right? It's a fairly simple net though. Cool. I see no reason not to merge this immediately. Going to merge this. And what I'm going to do, Kyung, is we'll see if I can repro this, the training. And I'll see if I can do it on the Puffer 4C networks. And we'll compare the perf. That should be good. Did this change make the training speed faster or slower, by the way? Similar? Okay. Cool. X-Chat's laggy, yeah. Hey, that guy. There. Merge, yep. I'm fixing a couple things, and I guess I can go see if I can get this running for you guys real quick on Puffer 4. It shouldn't be that hard. Hang on. Back. Yeah, we'll just port up real quick. Scaffolding ratio is the new one. Yeah, scaffolding ratio. Cool. Is it scaffolding ratio? Is that like this probably? And then all this is going, oh yeah, it's right there. Perfect. And then all these stats, presumably. Let's see. Wait, didn't I fix it too? Didn't I fix, what do you mean didn't you fix it? This is new bindings for 4.0, right? Looks like the older version. It looked new to me. This is the new binding code though. Did you do binding code for 4.0? I fixed those in PR. You did binding code for 4. Really? Let me go check. I don't see any changes under extensions. So no, you didn't change for I don't see any files committed for the 4.0 bindings. The 4.0 bindings are different. No big deal. There, that's something. Change for 3.0 bindings, yeah. Let's go fix your network. Is the ob size different? Is it 289 still? Wait, 18. Oh, it's 16. Four actions. This. Hey, Weston. How's it going, man? Cranking on some dev. Is it just the encoder? It is just the encoder, right? G2048 encoder. Nothing else. That's easy enough. Nearing the end of neurofeedback. I've gone over 2 months without touching any code. I hope you're doing better, man. I hope you're doing better. I've been in Florida. I ended up just being in like in California for like 2 days on the way back. But I hope you're doing better there. take a look. The new one, it's just a slight different encoder, right? Make sure it does it correctly. Near. Encoder, just this is basically the same, and then you just add this value embed ops.long. How is this 18? Oh, it is 18, okay. Allergies cleared up? Wait, doing a lot better actually. Neurostim helped with sleep, can fall asleep within 30 minutes, not 3 hours. That's way better, man. Allergies also cleared up. Hey, health's the most important thing. You need to absolutely take care of that. You got time for other stuff after. You don't fix health, you don't have time for anything. $18, not $16. Oops. Wait. Oh, do you need separate policy and value heads now? Do we not need that? It was like that before. I'm gonna try it without that. Do you think that's important that they're separated? It's kind of a pain in the ass otherwise. Having ablated? Damn it. Okay, I'll tell you what we can do. Yeah, we'll make it match. It's just gonna be annoying. I separated them for convenience. It's the decoder that's a pain in the ass. I'll just have to ablate it a little bit. We have this thing where the kernel expects, we have this like fused decoder kernel essentially that expects some stuff to be memory contiguous. There's a lot of just ludicrously optimized stuff in Puffer 4. Oh yeah, also that guy, multi-discrete turns out to be completely and utterly trivial if you have a custom kernel. It's literally more complicated in PyTorch than it is in CUDA. Why? Because you had to do this padding bullshit where like this padding bullshit, right? And then there were like it calls like 10 other kernels and stuff. And you literally just write one extra for loop in the CUDA and you're done and it's fast. No overhead. Literally faster than doing single discrete. It's pretty funny. Multi-discrete. Multinomial's the white whale. Ah, okay. What the heck was the multinomial for? Oh, the softmax? Yeah. Why do you think the big labs have not done this yet, Puffer? They're busy chasing shiny thing. Like, you can literally say that about everything, country. I've had, this has just been the last 10 years of my research has been like, I wonder why the big labs haven't done this. Well, they haven't done it. They're not doing it. I'm doing it. Whatever. Sampling for actions? Yeah, no, sampling for actions. It's really easy. It's multinomial to sample yeah, it's super easy. We have it fast now. There's no white whale. White whale's been hunted. It turns out Torch was just dumb. Wait, it is 16 obstin. Wait, how does it say 16 and then 18? Hmm. Bloody hell, what's this? Wait, how is this 18? This value embed is 18, but then the environment has dim 16. 16? High is 18. Oh, it's, I see. Okay, that's fine. Yeah, no, I see. I messed it up. Okay. I see. I see. Feel like all your research has been, wow, people are dumb and you're right. Yeah, that's pretty much how it goes. What's this? 470 something? Photograph some kernels on. Hang on, we need to have vec number. Yeah, this is totally wrong. Total agents. What are you working on now? PRs? I'm working just on a couple quick ones. because they're directly relevant for testing 4.0. How fast is this thing supposed to be, Kyung? $1.5 mil. Well, something's wrong. Oh wait, but you train with hang on. You train with 16K, don't you? Yeah, you train with 16K. Okay. I'm only getting 1.3. Wait, G2048 LSTM? It should be on Gelu though. Yeah, it's Gelu. Merge reward itself. Score's going up. Any tips for maximizing config for SPS? Well, it doesn't make any. There's no intuition in Puffer 3 because Torch is a mess. So things that should work a certain way because of the hardware don't work that way. With Puffer 4, it's just like bigger batch faster, more agents faster. But at some point, more agent stops helping actually learn faster, just like increase SPS. Now things at 1,000 score in the first 2 minutes. Let's see, what were we supposed to match for this, for the curve? What's the reach stats? Oh yeah, well that's just a Puffer 4 thing. I haven't exported all the stats yet, man. They are there, but like the once I add the hook, like they'll just show up for all the M's. All your custom stats will just show up. But I still have to do that. Yeah, no, I didn't delete it, dude. It's actually like the hooks, I actually have all the stats written out already there. It just needs to be turned on, essentially. Thank you for the 1B link. Let's see. What do we want? We want score. Where we at? We're at 250 mil. Oh, it crashed. Lovely. Okay. Well, something wrong. We crashed it. The obs became a single mem copy. What do you mean? Yeah, so this crashed, so that's not good. we have to do more stability tests. It did get 1,000 something pretty quick in the first couple minutes. 2 minutes, so it would have been like here. Okay, hard to say. Obs buffer. Oh yeah, that's nice. That's very nice. Blobs network. Hey, I'm hoping we can use this for a ton of research now. I'm gonna have to run some stuff on this. I would love to know why it's not any faster in Puffer 4. That would be good to know. Because this net is like ludicrously optimized. I mean, probably if I just do this. Here, how fast does this go if I just do that? Yeah, so that goes to 3.4 mil immediately. Man, 3.5. Well, scale's pretty nice. In Puffer 4, if you just give stuff like really low overhead. Here. Oh, again, this is weird. Alright, well, we'll use this as a test end then, because there's a bunch of things that aren't working the way they work on the other ends. Probably something is odd. Maybe the 32K mini batches. Not sure. Alright, that is integrated though. Okay. Drive environment next. How do we download this stupid thing, man? Fucking Hugging Face, I swear. What is the command to run this stupid thing? I swear. The lack of the, like, just not having the command here always drives me nuts because I always forget this thing. Where is the bloody command? It's on here? Yes, here it is. Okay, this is what we want. Yeah, these docs are good. It's just the other one is dated. But wait, this is open motion. Yeah, this is what we want, right? I download the wrong freaking. Does not have CLI. Not found. Do you have to open and close the stupid term? Stupid, man. Did they change it? I swear. What? Agents rotating the max tiles. It didn't make difference. Well, we have an environment to sweep and to test once we have stable everything, you know? It just made a .zip, which is not what it's. How much crap is there in this? Drive running was crazy. I mean, it's just like, it's stupid Hugging Face. I swear. They just did this release last week, and apparently they've already, like, screwed with their CLI yet again. Okay, what we're gonna do is PufferLib ocean. Resources drive binary map underscore underscore dot bin, right? Okay, so we do like this. There. How? Stupid thing, man. This like specific type of thing to deal with pisses me off so much. This processed big slash training. See it come. Data processed. Okay. Finally. Data. I didn't need 10,000 maps, but we got 10,000 maps. Processed in god-awful Python. I'm gonna just port all this crap, I swear. Okay. $10K files. Okay, cool. Oops. Okay, now we do have the binaries. Good. We can ignore this put and get. This my shared thing. Yeah, Claude can 100% do this. This is easy. Because we basically have set everything up, right? All this needs to do is get ported over to not use PyOpt bullshit. Where the maps get opened? Sludge overhead can't even give me floppy. That you're using it to think for you. You've already lost. Stop, like, by now you literally could have written that thing yourself and have learned a ton in the process. Yeah, we don't want this in NS, right? Load binary. This thing not have free env entities. Oh, I see, yeah. And then it just makes a dummy env. Okay. I see. So this is gonna do it on load. We don't need to do it twice. Do I need to do that vec total agents vec number? Whoops. Let's go grab this. Gotta go pay the taxes here. Wrong browser. Okay. School. Come on. Okay. I just added credits. It's a scam. There. Now work. This is actually not that complicated of a piece of code. It's pretty much just moshing together two other things. It is fiddly though, so it does need to be done correctly. Yeah, this is a very, this 2048 env is very, very nice. Still keeps doing better as well. We can run it for longer. 1.5 mil. So the goal here, right, is to just go over the maps, load them into the env, update the init method such that it already has the map loaded. It should be a couple very small changes to the drive H file. And it should end up looking pretty much like the myShared function did before, except without the Python API stuff. There's going to be some additional oddity with the padding, because you have to handle the padding manually. But that's just going to be like a loop over the buffer size. Other than that, it should be pretty straightforward. HDs is null. Skip loading. It's fine. It's fine. Okay, this is the full function. Num buffers, agents per buffer, good. All of our configs with dict get, which is just as before. This is fine. Current buffer plus the num buffers. You seed, you get a random index. This is copied over from here. You initialize. This is redundant because it's collect. Okay, if it's full, you free it and you move to the next buffer, yep. Otherwise, you fit it. And numems plus plus full. Yep. This is like mashed together from 3 different things that I'd written before. This is fine. It's actually way simpler if you look at this than the previous one. So, moving in the right direction. Back to numems. So now we have env num agents. We no longer need this one. It should be num total agents. 496 total agents. Or let's say 1 or 2 total agents. Redefinition of float 3. Why do we have float 3? Previous definition. Ah, okay. That's annoying. I actually don't know what the standard thing to do with this is. Probably we shouldn't have the include set up like this. No, we need this. That's really freaking obnoxious, isn't it? Yeah, it's really freaking obnoxious. What do we do about that? I'm trying to think how I would fix this. Like, I want to go mess with this and not include vector functions. I'm not gonna make it a DLL. This is already a freaking DL. Like, it is already a DLL. That's so obnoxious. It's so incredibly obnoxious. I don't think you can. Okay, I'm gonna try that. Just because, like, CUDA's big, right? Ideally, you shouldn't have to be worrying about name conflicts when you're making your env. Huh? Oh, wait, what? somewhere. Okay, that's weird. Human agent index. Okay. Seg fault. Okay, seg faults. Let's see what this does. It's the malloc. No such file. Cool. Oh, come on, you messed up my terminal color. No, we're good. Okay, no, this works. So it is a genuine seg fault. PufferLib. Rollout copy graphs. Use CUDA graph. That's weird. We take CUDA graphs off and we retry maybe? Oh, it works without CUDA graphs. Interesting. Let's try if it does an OOM. Let's see if it does an OOM like this. Yeah, 1.1 mil SPS it says. And then somehow it leaks. It's train leak memory. How the hell would train leak memory, man? No kernels? Nice bump from kernels. So train leaks memory, really? This is stable. Okay. I mean, I just don't recommend trying to vibe code like freaking complicated RL stuff. There. Let's say that's possible the kernel leaks memory. Okay, we can't graph this for some weirdo reason, is the thing. What about this? Is this out of memory? That's his problem. Learning something, maybe? Oh yeah, 1848 is the ob size, I suppose. Seven by 13. Ob space. Double actions, float terms, this is all correct. Five. Floating double. Size. Yeah, I wonder about this because this is weird. Looks like it's learning something, but it's hard to say. Hmm. Can we graph this is my question. Let's see if this OMs. Oh yeah, they're just OLMs. I don't even know how that's possible, man. Oh, there we go. Mm-hmm. Yeah, so something with the new CUDA binding screws it. Okay, yeah, it's the new binding specifically. Oh, that's bizarre that that would cause OOM. I don't know how. That's weird. That's like weird, super weird. I wasn't expecting that. I have absolutely no idea how the hell Kuda does that. That's bizarre. Presumably conflicting types. Well, I didn't say that you could put it there. Wait, no, this is fine. Yes. Okay, yeah, this is fine. Hey Spencer, I'm working on getting the drive env into Puffer 4. There's still instant OLMs, huh? I mean, now I gotta go look at how stuff was before. Any of the oddities? I have no idea how we're gonna do the resets thing. That one's pretty rough. There's a lot of stuff that's gonna be jank, man. I'm basically just gonna see, like, I think the thing that I would like help with is if we can at least get a demo of the speed training on something, and then be like, hey, it's gonna take some porting work to get the full thing on here, we'd be good. It's not straightforward because you have to remake the whole bloody end the way it's done right now. I think we can figure it out. It's pain in the ass though. Maybe not that bad. So we definitely can't remake the whole vec env. I think we can rebind the existing memory though. It's a little weird. But the more I think about it, the more I think it'll be okay, and ultimately it'll be simpler than what we had before. But like, yeah, it'll be a little bit of work. Well, now this is bizarre because now everything's just OMA. Delta, delete and rebuild. Yeah. Okay, so it doesn't OOM with coup de grace. Interesting. We had one guy, so we got a contribution to the fused scan kernel that made it a little bit faster. I think we're gonna be close to 11 mil SPS once we get the PPO loss kernel to work. I think it'll peak like 10.7, 10.9. What are we using Ray math for here? Ice in Texas is scary. Oh yeah. Make sure you get your winter coat. It's really cold, man. Real cold in Texas. Laughs in Boston. Is there a thing we're using Ray math for? Is it vector 3? Yeah, we are. Okay. What do we do? This is really dumb that we have to, like, handle namespace collision with frickin' CUDA just because we're including it. Weird thing, man. Just weird. Actually, real quick. Was it? It's kernels. It's like this is the thing that makes it slow. Yeah, I don't know how that OOMs. That's weird. But like, okay. How long have I been live for? 8 hours? I feel like I could just keep going all night if I had, I just got a little bit of food. Maybe we'll do that. Like, this shit just needs to work. This runs in this table, right? Get food now. Only 5:10. I'll go check in a second. M's total agents. Wait, 8192 segments. Why segments like this? Oh, that's the issue, right? 8192 segments. Well, this is not the error, but just make sure it's not like memory being ridiculous. Just make sure it's not memory being ridiculous. Okay, it's not memory being ridiculous. Good. Okay, so just like false. Let's figure out why this thing doesn't work without coup de graphs. Because look, there's a breakout. Custom kernel. It does an OOM with kernels false. Huh. Really? So with kernels true, okay. What about this? Ah, I see, I see. This does not OOM, right? No, this does not like insta OOM. Okay. So this does train. And now we have to figure out there is something wrong. If false, so it's not this one. Hmm. I'm gonna have to think about this one. I'm gonna have to think about this one. I'll be right back. Let me use the restroom. Let me go grab something. I'll be right back. Ah. Okay. So let me just verify this is what I think it is, because this is ridiculous. All right, so we got, is it? So this works, right? Kernel's on. OM. Photographs on. Works. And kernel's on. Okay, so what we're gonna do. Go like this. True. Do Just gonna figure out which one of these it is. Memory. Okay, not this one. It's this one. We'll try without the checkpointing. Both of these? It is, isn't it? Spencer Snowden, I'm going to try to see if I can get PufferLib compatible supervised model. Testing will be way faster, get accurate ELO estimates. Oh yeah, that'd be really good. Wish me luck, yep. I don't understand how the hell this can OM. Like, huh? Did these not get cleared or something? Like, that doesn't make any sense to me at all. Saved for backwards. I mean, that would do it. Probably very quickly as well, right? Because Puffer just cranks data. Let me try this. Clean up after backward. All right, we'll try this. That's fixed, right? 7.7. Wait. Well, it's not coup de graft. Works. Weird. Very weird. Still just as fast. take any perfects for this. Do we seg fault? Yeah, now we still seg fault. Okay. Weird that would like have any influence though. It shouldn't. I remember there being weird stuff with this, the problem. Wait, set active agents. This is fun. I just remember them like having done something weird with this. Yeah, see, this is not going to be usable. Hmm. Okay, I'm a little bit confused because yeah, it doesn't do the stuff in the middle. Right, so this is set active agent. Dynamics model. Name for cache indices. Some ops. Agent count. I see, set active agent count. I don't like this. Yeah, because it's like skipping some stuff. It's kind of weird. Funny. Setup config. Okay, try this. And then init gets returned to its original state. Which is good. So now much better, right? I'm sure that leaks some VRAM, but still seg faults. Can we at least run normal train? We run normal train. Hopefully. Yes. Yes, we can. It runs as before, though. How the hell would this mess with our ability to graph something? What? Does that make sense? Let me make sure that I didn't screw up the buffer somehow. Let's see, I'm gonna move to the next buffer. Blog post. I did start writing it, though. I did start writing it, Igor. I have something of a draft. See, progress. It's annoying because my opinion actually keeps changing of it the more I use it. Like, it still feels very useful, but it feels very stupid now that I've used it for a little longer. Like, definitely useful, but very stupid. Yeah. Fuck. Default delete. See, this is why C++ is so shit. Deallocate. J. You know, I wonder if I hard-coded... Hang on, let me just make sure I didn't hard-code some dumb thing here. Whoops. No, see, num buffers. Yeah, this doesn't fix it. Okay. Okay, I mean, I did make it of 2 here. Oh, I know what it is. I know what it is. I know what it is. Alright, Dad. Well, there's the bug fixed, and there's 700,000 steps per second. So they're going to be very happy about that. I got to fix this stuff. I think what I'm going to do is I'm going to go run for a short dinner, and pending that, I think I should be able to do a night stream. We'll see. I'm going to see how I'm feeling, but we're making really good progress, so I think it makes sense to do a bit more today. I could do something tomorrow, but I think it's generally better I at least take one day off a week. So, thank you all. If you're interested in my stuff generally and want to support my work for free, feed the Puffer a star on GitHub. We're almost to 5,000. You can join Discord to get involved with dev. Follow me on X for more RL content, and I will be back